errors, watch so that you don't make these common errors. These are the common errors in calculus. These are the common algebra errors. This is literally a whole section in the pre-calculus book, which this is considered pre-calculus. Remember how many of you raised your hand saying you want to do calculus 1 and 2 next year. So let's start preparing you now so you can do that, okay? So errors involving parentheses. These are some errors we see in calculus. Is it true that a minus the parenthesis of x minus b equals a minus x minus b? No, this is really a, and then that's negative 1 times x, which is negative x. Negative 1 times negative b should be plus b. Correct, everybody? So we fix that. Next thing, a squared plus b squared, people will break the forbidden rule and do a squared plus b squared, which we know is absolutely not true. We would rewrite that out as a plus b times a plus b, and then we would double distribute and combine like terms. Next thing we see in calculus is people will say 1/2 times a times 1/2 times b. They'll say, oh, we're going to factor out a 1/2. But notice, this is not two terms. This is technically one term, correct? Factoring only happens if you have multiple terms for the most part. Or you got to think correctly here. So isn't this really just, so this is not true. Isn't this really 1/2 times 1/2 times a times b?
Sure.
Right? Yeah. So this is really 1/4 AB. Everybody good with that? Yeah. So that's just some errors you see. Next thing, errors involving parentheses, is people will do these things like they'll factor out, and I like the fact that they're seeing, okay, they'll say that this equals this. Now, can anyone see why that's not true? Yeah? What's squared as well? Yep, 3 should be squared. Sorry, 3 should be squared as well. Now, here's why, guys. We factored out a 3. That's fine. Left would be x plus 2. That's absolutely beautiful. And then squared. So we know we have to have 3 squared and x plus 2 squared. Everybody comfortable with that? Okay, so just don't make little errors like that. That's what gets people. Okay, errors involving fractions. People will see this. A over x minus b, and they'll split it up and say, okay, that's really a over x plus a over b. That's absolutely not true. Correct, everybody? If it's connected by addition down here, that's the entire denominator. It's connected. You cannot split this one up. Does everybody understand? So we would not split that up. That's not true. Does everybody see? Anybody have questions on why that is? All right. People will say this. We have x divided by a divided by b. They'll say it equals bx over a. Now let's do the actual algebra. Isn't that b over 1? Dividing fractions easy as pie. You flip the second one and multiply. So our answer should be x over ab, correct? Okay. Adding fractions. People will just say, oh, we have 1 over a plus 1 over b. That's 1 over a plus b. Well, you can't just add straight across. We have to have common denominators. We're going to see this a ton today. So we do b over b, a over a. Now our the denominator is the same. So now we can add straight across. b plus a on top, b plus a, all over what? ba. Okay, very good. Any questions? Okay, errors involving fractions. People will say this. 1/3 x is equal to 1 over 3x. That is not true. Isn't this technically 1/3 times x over 1? So it's x over 3. So this is not true. That is true. Everybody seeing? Am I going too fast? Okay, people will say this. 1 over x plus 2 is equal to 1 over x plus 2. Can't do that. We have 1 over x plus 2 over 1. Let's get a common denominator so we actually can combine these. X over x. So we'll have 1 plus 2x on top and on bottom x. So that's not true. Okay, good. Next one, errors involving exponents. People will see you raise a power to a power and they'll add. But when you raise a power to a power, we multiply. So that's not true. It should be x to the 6, right? Then when people see these things being multiplied, when they see the bases being multiplied, they'll multiply the exponents. That's not true. When you multiply the same base, you add your exponents. So it should be x to the 5th. People will see 2x to the 3rd and think that 2 is also to the 3rd power. That's not true, correct? This is simply 2 times x to the 3rd. Okay. Couple more things. This is the big one. I'm not kidding. I can't tell you how many people do this wrong. And some of you were doing it wrong when we were simplifying things earlier. People will say, okay, we have 1 over x squared minus x to the third. Oh, okay, so since they're flipped over a fraction, then we're going to bring them up. But since there's a subtraction sign, you can't just bring them up individually. Now I'll make sense of why. Isn't this truly, if we wanted to flip this over a fraction, are we looking at all of this raised to the first power, correct everybody? It's connected because of the subtraction. Aren't they connected? Yeah. So that's really x squared minus x cubed to the -1 power. Isn't that true? Now, is it appropriate to just square that? No. So would it be appropriate to just -1 that, -1 that? No. So does everybody see why that rule is in place? Why you cannot do that. So this would be as far as we go. Okay, errors involving radicals. The square root of 5x, you can't just pull out a 5. 5 squares of x is not true. This doesn't simplify. Everybody watch. People will say, the square root of x squared plus a squared, we can just square that. Because of the addition sign, you can't do that. Because think about why. Isn't this x squared plus a squared to the 1/2 power? Can we just square that? No. So can we just half power that? No. Does everybody understand? Okay. Now right here, people will say, oh, let's factor out the negative, and then we have x minus a. So let's think about this correctly. If we factored out -1, that would leave us with x minus a. True? What's the square root of -1? I, correct? So we don't just pull out a negative. Yeah, everybody know that. Now, we would leave it like this in calculus. We wouldn't even factor out the negative. Okay, errors involving dividing out. This is the biggest one. People will say, oh, look, the a's divide out, become 1. 1 plus bx. Wasn't bx also divided by a? So it would be appropriate to split it up as long as you keep both the top divided by the bottom. So a over a plus bx over a. Think about why that works, because then we could recombine them back together because they have a common denominator. Does everybody see? So this would simplify appropriately to be 1 plus bx over a. That would be appropriate. This would not. Okay, looking at this one, people will say, oh, the a's, what do they do? Oh, they'll say, those a's divide out. That is not true. We really could split it up, though, and do a over a plus a over x over a. So that would be 1 plus x. That would be the correct simplification. 1 plus x. Everybody good? We're almost there. Errors involving dividing out. People will say that this simplifies to be this. Why is this not true? Let's look at it. 1 plus x over x becomes 1 over 2, right? Isn't that true? Yeah. I didn't break any algebra errors. Isn't that if you simplify? And that's okay. So this would be 1.5. 3/2 is how we write it in calculus. Okay? Or we could get a common denominator and then simplify. But that's what it's going to simplify to be. Okay, so now this is not, these are good. These ones are okay. So now we're switching. I'm just showing you some ways to write things differently. In calculus, you always take things and write them so that they're easier to integrate, which you don't know what that means yet, but later you will. So we're just looking at the algebra here. Do you guys see how if we have 5x to the 4th divided by 8, it is the same thing as pulling out a 5/8 and timesing by x to the 4th? That is true, correct? It is. Okay? So it would be in calculus very helpful if you had something like this, x squared plus 3x divided by -6, to rewrite it as this. Say, I know this is really, pull out a -1 over 6, and then left is times x squared plus 3x. Does everybody see how I just rewrote that? Okay. Couple more, then we're just going to start practicing off your worksheet. So, some unusual factoring you could see in calculus. Given this, it might be useful to factor out a 2. So let's pull out a 2. Even though they don't all divide by 2, we can still pull out a 2 as long as we do the correct steps. So wouldn't we divide by 2, divide by 2, divide by 2? Sure. To write what's left in our parentheses. So then left would be x squared minus x over 2 minus 3/2. Yes. Okay. Sometimes it's helpful in calculus to unsimplify things, and what I mean by that is if given this, if you can recognize that it's the same thing as this is a lot easier to integrate. So does everybody see how those are the same thing? Isn't that okay? Okay. Looking at this, we know this is 7 over 2x minus 3 to the 1/2 power. And now we would rather have it multiplication. So I'm going to pull that up and do 7 times 2x minus 3 to the negative 1/2. Does everybody see how I just rewrote it? Okay. Okay, sometimes it's helpful to write things as a sum of just one fraction, or just splitting this up differently sometimes helps. And you'll learn in calculus with different problems what would be more useful. So everybody, look at this. This is really x plus 2x squared plus 1 over x to the 1/2 power, correct? So if we pull, and now we need to divide each of those things by x to the 1/2. So split it up. That's x over x to the 1/2 plus 2x squared over x to the 1/2, isn't that true? Plus 1 over x to the 1/2. And then instead of having it as division, multiplication is usually easier in calculus. So you pull up x to the negative 1/2. Everybody good with that? And so we have x times x to the negative 1/2, and then we have 2x squared times x to the negative 1/2, and that could simplify, and that could simplify, so we could keep simplifying, and then we would have 1 times x to the negative 1/2. So we could keep simplifying this. This is x to the 1. When you multiply, you add. What's 1 minus 1/2? So we have x to the 1/2 plus 2x. What's 2 minus 1/2? Yep, 3/2, and then we have plus x to the negative 1/2. That would be the prettiest way in calculus to see it. Good question. Can we combine those two? That's a great question. I'm actually really glad you asked. But do they have the same? Is x squared plus x to the negative 2? Can you add those? No, they're very different. Isn't this x squared plus 1 over x squared? Are those the same? Can you add them? No, so you can't add them. Good question. I'm glad you asked that because these are algebra things that should be asked. So does everybody get now? That was a really good question that we can't combine those two. Okay. Looking at this one, it would be sometimes useful to split this up. So as long as we keep the entire denominator together, we're good. So that's 1 over x squared plus 1 plus x over x squared plus 1 because we kept our denominators the same so we could combine them. And we'd be back here. Okay. All right. So now sometimes it's useful to insert factors and terms. So notice this. It might be useful to insert 1/2. Well, we've changed the problem, so I've also got to insert times 2. Because 2 times 1/2 equals 1. So we just inserted a fancy 1. So we didn't change the problem. So these are just little things you might see. This and this are the same. So think about y. 4x squared divided by 9. Isn't that the same thing as x squared divided by 9/4? Dividing fractions is easy as pie. You flip the second fraction and multiply. So doesn't that put us back here? Does everybody see that? You don't see it. Okay, x over 1. Flip the second, 4. And then 9's on bottom, so that'd be 4x squared over 9. Good question. So looking at this, we have minus y squared divided by 1/4. It's the same as this because flip the second, negative y over 1, and multiply. Is everybody seeing it now? Okay. Okay. Sometimes you'll see, and you will insert things in calculus that'll be like adding a fancy 0. So x over x plus 1, you might rewrite it as x on top plus 1 minus 1. So we inserted this fancy 0. Does everybody see that? And you'll get, like right now, you're like, well, I don't see the purpose, but you will in calculus see when you're learning those things. So then we could split it up as long as we keep the entire denominator x plus 1. So we really have x over x plus 1, and then we have plus 1 over x plus 1. And then we have minus 1 over x plus 1. What did I do here? What's a negative 1? I'm just trying to remember to see the point of this one, like from the book. How'd they get 1? Oh, that's what they're doing. Okay, I like that. Okay. Amelia, so you're seeing it. So we could regroup this as long as we keep it. So that's really x. Let's group these two. That's okay, right? That's what they're doing. Okay. So x plus 1 plus negative 1 over x plus 1. Isn't this the same thing? And that's okay, right? There's a common denominator. So you're right. That is a 1 minus 1 over x plus 1. Good. Good seeing that. Those are the I's that you need in calculus. Okay, so describe, here we go. We're starting with the worksheet, number 7. Oh. Obviously, okay, these are off your worksheet now. Do it on your own sheet of paper because you're not going to be able to fit it. So it says, describe and correct the error. So there's an X through it because it is not correct for some reason. So it says A times XY equals AX over AY. But that's not true, correct? It's A over 1, right? So we would say don't multiply A to top and bottom. We multiply straight across. It's A over 1. You just say don't multiply A to top and bottom. And then the true answer should be AX over 1 times Y is Y. The next one, number 9, it says, oh, you can split this up and do the square root of x plus 9 equals the square root of x plus 3. We can't split it up because we know, this is via reasoning, this is really x plus 9 to the 1/2. And we know that it would be breaking the forbidden rule to just raise that to the 1/2 power and raise that to the 1/2 power. That's breaking the forbidden rule. We can't do that. So this is the answer. Well, this would be the appropriate answer or this. But in calculus, anytime you're dealing with radicals, you rewrite them as rational exponents. So this is probably what we're looking for here. That's as far as we can go. The x plus 9 to the 1/2 power. Yeah, don't break the forbidden rule. Okay, let's do 17. Describe and correct the error. We have 3 plus 4 over x plus y. They added straight across, which we know you can't do that. You say you need a common denominator to add fractions. That's what you'd answer as in words. So then you would get a common denominator. Y over y, x over x. So the correct answer will be 3y plus 4x all over xy. Yeah. Right, everybody? Were we able to see it that fast, or was that too fast?
No, it's perfect.
Okay. Number 12. We have 6x plus y divided by 6x minus y. We have people doing 6's divide out. Well, you would say, when it comes to addition, you cannot just divide out on sides. You know what I mean? Just take this piece and divide it with this piece. It's got to be multiplication. It's got to be factored out. So you just say you can't divide out things when they have addition and subtraction. So this is the correct answer right here. Or in calculus, it might be useful to write it as multiplication. So we could write it as this. 6x plus y on top times 6x minus y raised to the negative 1 power, correct? 6x minus y to the negative 1 power. I brought this up.
Yeah.
Everybody see? Okay, so either answer, this is fine, or this. Okay, number 19, let's go on to the next section here. I'm just going to make you do a few out of each section, so let's go to this next section. 19, it says insert the required factor. I honestly think they should not even give you. Notice they give you, and they make it too easy on you. They give you a bunch of options. But so I should just be able to look at this and be able to put in what I should insert in. So what would make this equal? We have 3x plus 2. What would make it equal if we have 1/5? Yeah. 3x plus 2. Very good. Everybody see that? Okay, that'll be our answer then. Number 21. A little bit harder, but I know you can do it. Don't even look at your options. Just push yourself. What's going to be inserted in to make this a true statement? Good. 2x squared plus x plus 5, you said. Yep. What would it be? If I put 5/3, that's a good thought. That would be, let's multiply back. Okay, perfect. That would be right. So 15 is correct. Very good. Good fix. 15 divided by 3 is 5. Very good. Okay, 41. Now it's new directions. It says, write the expression using negative exponents. So in calculus, you'll have stuff split apart like this. You'll be integrating it in addition and subtraction. You don't know what I mean by integrate, but you can look at it in sections. You can integrate that. You would want it as multiplication, so that's what we're going to practice. So let's just focus on this section. That's 4 times parentheses 3 and x to the negative 1. True? Let's now focus on this section. Now, nothing more simplifies here. We're just going to leave it, or else we'll end up back here. And then we have plus 4 times x to the negative 4 for that section. And then for this section, okay, it is always more helpful in calculus to have rational exponents. So we focus on this piece and rewrite it with rational exponents. So won't that be on, right now it'll be 7x over, won't that be 2x raised to the 1 over 3, correct? Roots are on bottom, powers on top. Not true? So then we would have minus 7x times parentheses 2x to the negative 1/3. That is rewriting it with negative exponents. And that would be really quite easy to integrate, which is a calculus thing, like I said. Okay, awesome. Number 43, write each fraction as the sum of 2 or more terms. Your answers may vary. You can do this a couple different ways. So write each fraction as the sum of 2 or more terms. So basically we're writing this and splitting it up. This would be a lot easier, so let's do that. So, like I said, answers could vary. So I'm going to do 16 over x minus 5x over x minus x squared over x. Isn't that okay, algebraically? Yeah. And now why would this be easier? And if you were in calculus, you could see why, but this doesn't simplify. Well, actually, let's write it as 16 times x to the negative 1. And then don't those x's divide out? Yeah. Minus 5, oh, that's beautiful. And then we have minus x. Oh man, that is so much prettier when it comes to calculus stuff than that. Okay, so you guys see how to do that? Answers may vary. You could have chose to split it up differently. Okay, number 50, this is when we get to the hard stuff, okay? This is the ones that take a while. You guys, look at it as I've got to be really careful algebraically, and I'm going to show all my work. Give yourself a brand new page for every problem. I did. Every problem, I gave myself a brand new page. Here we go, number 50. Simplify the expression. What you've got to do is look at it in pieces and simplify it in pieces and be really careful not to make errors. So let me tell you, when I did this, I was sitting there and I was working and I was doing this, and so I was multitasking, and so I was breaking all these algebra rules. Like, let me show you what I did originally. I took and I flipped that over a fraction and put it down here. That would be wrong. You can't do that. See how that has a negative exponent? I took and flipped that down here. That's algebraically not correct. Because we're looking at, you'll see why, once we get going here. Yes. Yes. Good point. If that subtraction sign wasn't there, we could do that. Because then it would just be division. And so all would be well. Very good question. So because of the subtraction sign, we're just focusing on this top here. We've got to focus on this piece. So everybody, I'm going to focus on this piece for a second. Let's reorder this in a prettier order. So negative 3 times 2x is negative 6x. Okay, I'm going to show my work here. And then we have times x to the 5th. So when you multiply the same base, you add your exponents. So we have negative 6x to the 6th. Now, you might simplify this a little different than me, but for the most part, algebra should come out correctly. So we have negative 6x, and then right now we have x squared plus 1 to the negative 4. Is everybody good with that? That was all this piece. I'm not done simplifying that though. I just reordered it. Yeah. 5x, 1x is 6x. Yep, good question. Okay, now I'm going to simplify that again. That's really negative 6x to the 6th divided by x squared plus 1 to the 4th power, correct? Yeah. Okay, now moving on, I'm going to change colors. And I'm going to focus on this piece. So I'm going to reorder it. 5x to the 4th. So I have minus 1 5x times 5x to the fourth. So that's negative 5x to the fourth. Is everybody caught up to me here? Yeah. And then we have our x squared plus 1 to the negative 3. So I'm going to flip that over a fraction. So then I have x squared plus 1 to the positive 3. Now that's just the top. No, ask me, because I bet other people have the question. How did I do what? Oh, good question. So we have a 5 here. So I'm reordering it. So negative 1 times 5 is negative 5. And then we have our x to the fourth. And then I just took and flipped that piece. And that's all over. This is how you should show your working. X to the raise the power to the power and you multiply. Now here's one thing you've got to note. You would not want to keep going and flip this yet. You'd want to keep simplifying this. We want it to be one fraction all combined together. So to add and subtract fractions, you have to have a common denominator. So let's get a common denominator just focusing on that piece. Is anybody feeling too overwhelmed yet? Yeah. Okay. So now we need to get a common denominator to combine this. This is where I'm focusing. So I need one more x squared plus 1 right here, because then we would have x squared plus 1 to the fourth over here as well, correct? Yeah. And then we could combine this. So we got to do that to the top and bottom. So we're getting a common denominator. So now I'm just focusing on this. I'm going to go ahead and distribute negative 5x to the fourth through. Is everybody up to here caught up? Negative 5x to the fourth times x squared is negative 5x to the sixth. Negative 5x to the fourth times positive 1 is negative 5x to the fourth, correct? And that's all over that to the fourth. I distributed the negative with it. Because it's still subtract, yeah. We would, because we got to distribute the negative through. Okay, so I'm going to show my work here so nobody gets too confused, hopefully. So you have, right now we have this, negative 6x to the 6th over x squared plus 1 to the fourth. Then we have minus 5x to the 6th minus 5x to the fourth. And that's all over x squared plus 1 to the fourth. Does everybody see where I'm at? Okay. So now I'm showing all my work so I don't mess up. So now aren't I going to now combine the top? Like terms. So any like terms, yep. Negative 6x to the 6 minus 5x to the 6 is how many x to the 6? So we have negative 11x to the 6 minus 5x to the fourth all over x squared plus 1 to the fourth. Yes, but so then we're not done, we still, yes. So we've already distributed the negative through. We chose back up here to distribute the negative through both, so now we've already distributed the negative. So now we're just combining like terms. So that negative is now distributed through, we're just combining. So we're not going to have parentheses anymore. We distributed it. Good question. Wait, last part then? Why is it not? You're just saying skip to the step basically?
Well, no, but like, yeah, pretty much, yes. But not having.
Yeah, so that's just skipping to the step. Yes, as long as you don't mess up. I'm showing all my work so I don't mess up. Yes. You guys, so watch this simpler example. 4 over x plus 1 minus 5 x plus 2 divided by x plus 3 or x plus 1. Won't we distribute negative 5x minus 10? Yeah. So then that's over x plus 1 and we have 4 over x plus 1. So now are we just combining like terms and we've already distributed the negative through, correct? So we're not going to change any signs now that we've distributed the negative through. So that's the same thing as up there. All right, any further questions? We're not done. So that's all divided by x to the 10th. We're almost there, guys. We are almost there. So we know now, because we have a fraction divided by a fraction, dividing fractions is easy as pi. We flip the second one and we multiply. So we're getting there. We're almost there. So we have, right here, we have negative 11x to the 6th minus 5x to the 4th divided by, like I said, I never skip steps in calculus. It's not worth making mistakes. X squared plus 1 to the 4th. And then we're timesing by, you flip the second, so 1 goes on top, and x to the 10th goes on bottom. Now my question for you is, can I continue to simplify? We know how to simplify fractions. We just did a unit on it. Don't we have to have it being multiplied to divide it out? Shouldn't we have things factored completely to actually simplify these correctly? Yeah. So let's factor out that top piece right there. So what's in common? Let's factor out an x to the 4th. So looking at this piece, I'm going to pull out x to the 4th, divide by x to the 4th. You can pull out negative x to the 4th. If that's the case, then divide by negative x to the 4th, divide by negative x to the 4th. So if that's the case, if you pulled out negative x to the 4th, left would be x11, x to the 2nd, plus 5. And that's all over x squared plus 1 to the 4th. And then we're timesing by 1 over x to the 10th. So everybody caught up to me mentally. Now we can simplify x's. We have an x to the 4th on top. The negative is not connected to it. That's negative 1 in front. So we're looking at x to the 4th divided by x to the 10th. What does that leave me with? X to the 6th on bottom. So we have an x to the 6th. So my final answer, then you'd say, okay, does any of this factor more? Nope. Doesn't look like it. So we have negative 1 technically, and then 11x squared plus 5. And then on bottom, we have our x to the 6th. And then we have our x squared plus 1 to the 4th. You could, I would not do that. I would see if you could factor it further, then it wouldn't be a bad idea to factor it, but look, here's why I don't. 11x squared plus 5 does not factor, so I know that nothing's going to divide out, so this is perfectly fine. Does that make sense, everybody? This is our final answer. We got there. What? You got it right, I promise. That'd be fast. Here we go. Number 54, I'm just going to start you off on what you should be looking at, and then, because I don't want to take away your options. Now with these ones, if I didn't get it right the first time, I didn't assign it, so I'll tell you which ones I did try and didn't get them right, so that I'm like, if I can't get it right the first time, then I'm not going to assign it. It's probably maybe too hard. We don't have online homework. Nope. Okay, here we go. Hey, pay attention. Yeah, this is the homework. Here we go. So with this one, are you listening? How we would start this one off is you'd say to yourself, how should I simplify it? Why does he freak out? I told you I'm not assigning all of them. And I would be reasonable. You just don't listen. 2x minus 1 to the 1/2 minus how would we rewrite this? I already know. You tell me. Okay, now subtracting fractions, we're going to want to combine them. We need to get a common denominator. What's my denominator right here? 1. So what's my least common denominator? 2x minus 1 to the, so we're going to multiply by 2x minus 1 to the 1/2. Do you want me to continue? Huh? Well, it takes away your option. I mean, it's just taking away options for you. Because I'm telling you, you have to do this many on this section, this many on this section. So from here, we are multiplying the same base, right? So what do we do with our exponents? Add them. So this is 2x minus 1 to the 1/2 plus 1/2 is 1. Great. And that's all over. I always show my work. In calculus, being lazy will hurt you. So minus x plus 2 over 2x minus 1 to the 1/2. So now I say to myself, can I combine my numerator at this point? Yes, our denominators are the same, and this one's coming out very pretty. Now look, 2x minus 1 to the first is simply 2x minus 1, correct? So aren't we just combining like terms on top, but we've got to distribute our negatives. So just looking on top, and a lot of times I'll write out top for myself. So we have 2x minus 1 minus x minus 2. And I'm going to just keep going with the top. So let's combine like terms. 2x minus x is x. Negative 1 minus 2 is minus 3. And that's all over 2x minus 1 to the 1/2 power. That's as simplified as it gets, right? There's nothing more we can do here. True? And we're good. Yes, and I would also accept if you pulled it up and did multiplication by negative 1/2. Great question. So this is acceptable. Or x minus 3 times 2x minus 1 to the negative 1/2. Isn't that the same thing? You wouldn't distribute because this is raised to negative 1/2. You can't just that. You know what I mean? This is good. Good as it gets. Okay. That's it for me. So